Continue examples of curve sketching. Now let's look this function first. This function, the domains are all real numbers. So the curve can be sketched over the whole entire real number domain. And let's see first, y is equal to x at those points. X is 0, pi, 2 pi, 3 pi, and so on. Now we are not considering negative because this is an odd function. So we just sketch the half of it, all real number positive. The other side just symmetric with respect to the origin, right? Now at those points, 0, 2 pi, 3 pi, and so on, the y is equal to x. So we draw this line. This is y equal to x. So at those points, 0, the curve passing this point, passing through this point, pi, 2 pi, 3 pi, and 4 pi, and so on, right? We just consider the positive side. The other side is symmetric. So, okay, now this is, we are looking for information so we can sketch the curve, right? And then consider the derivative. Y derivative is equal to 1 plus cosine x. So that function is 0 or positive. So we know that the function is not decreasing. It's increasing or 0, but not decreasing. So the curve is something like that, always increasing. And at the derivative equal to 0, then x will be equal to, we're just looking for cosine x equals negative 1, right? So that will be equal to x is equal x cosine x is equal to negative 1. So x will be equal to pi, right? 3 pi, 5 pi, 7 pi, and so on. Now we discussed positive side first. Therefore, at this point, the slope of tangent is 0. So slope is the curve is tangent to this horizontal line, 1 pi, 3 pi. So this point, right? The curve is tangent to the horizontal line, 5 pi, and so on, so on. Now then, second derivative is equal to negative sine x. So at second derivative equal to 0, x is equal to 0, pi, 2 pi, 3 pi, and 4 pi, and so on. So at these points, likely we have a point of inflection. So at this point, they are likely point of inflections. So okay, now we can sketch the curve. Well, the curve is non-decreasing. The curve is tending to horizontal line at these points. The curve passing through these points on the y=axis, right? So we can sketch the curve now. Let me use. Okay, so let's see. Oh well, we have something else. Look, at those points like point of the inflection, right? Say at this point, what's the derivative? The derivative will be equal to 2, which means at this point the slope of tangent is 2. Now this is the slope of the 1, right? Slope to 2 is something like this. Tangent to this one, right? At pi, the slope tangent is 0. At 2 pi, you put it there, the derivative will be equal to 2. So therefore slope will be this. The slope of tangent line. The slope of tangent line, 2. Now we are ready to sketch the curve. The tangent to this line, right? And tangent to this line, it goes like this. And horizontal tangent line, and the slope to this one, and the horizontal tangent line, and the slope to this one. Yeah, so that is a sine curve. Then symmetric to this origin. That means you rotate the curve 180 degrees. You get the other half. Okay, that is sine curve. So this horizontal point inflection, horizontal tangent line, slope of tangent is 2, slope of tangent is 2. Not decreasing, always increasing, or the tangent to slope is 0. So okay, so that is the curve of y equal to sine x. Now let's have another one. Y equal to x minus sine x. I put these two curves on the same graph because we can have a comparison, right? So we will have a better understanding. Now, this is also all the function. So we just draw half of this curve and the other half symmetrical with respect to origin. And this function the y will be equal to x when x is equal to 0, pi, 2 pi, 3 pi, 4 pi, and so on. So at this point, at pi, this point, at 3 pi, this point, at 4 pi, this point, at these points, y equal to x. So this is a straight line, y equal to x, right? So the curve passing through this point, and this point, and this point, and this point, and so on. While curve sketching, we are collecting information, right? Now then, the first derivative is equal to 1 minus cosine x. So this curve will never be negative, which means this curve the curve of this function is a non-decreasing function, non-decreasing curve, and at derivative first derivative equal to 0, x is equal to 0, 2 pi, 4 pi, 6 pi, and so on. That means at this point, at 4 pi, the slope of tangent is 0. So at this point, at 0, this is the tangent, horizontal tangent, horizontal tangent, horizontal tangent. Well, then the second derivative is a positive sign x, and second derivative equal to 0, x is equal to x is equal to 0, pi, 2 pi, 3 pi, 4 pi, and so on. Right? So at this point, pi, 2 pi, 3 pi, these points, they are points of inflections. And this first derivative. Now, when cosine x is negative 1, then derivative of y with respect to x will be equal to 2. So that means when x is equal to pi, pi, 3 pi, 5 pi, the tangent will be equal to 0, tangent line, the slope. So by considering these, we can sketch the curve, at 0 is the slope of the tangent slope is 0. At this one, at pi, the derivative will be equal to 2. So at this point, that the slope of tangent line to the curve, to this curve, is 2. So this is gradient, the slope is 2. So that will be the curve. And this is also point inflection. Then horizontal tangent line, and tangent slope is 2, and slope is 0, and so on, right? So this is the same thing, horizontal tangent line. Okay, so the red one is y equal to x minus sine x. So I purposely put these two curves on the same coordinate system because we will have a comparison, so we will have a better understanding. Okay, I think this is interesting. Now we can derive the curve this way. Now we have a sine curve. We have a y equal to x, right? This is y equal to x. This is equal to sine x. Now if you consider y is equal to x plus sine x, which means that we added this value by a sine value, right? So, so 0 at a 0 is a 0 because 0 at a 0 is 0. Now, this point is x. This point is x, right? So this is also x. X plus sine x. So sine x is this. This is sine x. So we add a sine x. So we have this point. And this is 0. Sine is 0. So x equal to this one. X equal to x itself. And at the same time that this is x. And this sine value is negative. So minus this way. See the x can here. And this one is x. This one is x plus sine x. Plus sine x. And then this is x, right? And this is x, sine x negative, minus sine x become here. And this one is x. And this one is, this is x and the plus sine x. So we have these points, right? See. Yeah, and I have these points. Yeah, that will be x plus sine x. Now, for the red one, y equals to x minus sine x. We simply mean we draw x value, y equals x, right? This is x. Then minus sine x. So this is x minus sine x. Becomes here, right? This is x not changed because this is 0. This value minus this becomes adding. So this is the point. This is the point. This is the point. This is the point. Minus. So become this one. Become this one. And the minus becomes this one. Sine and minus. This is not change. So we will have this one, right? This and point inflection. Then this will be y equals x sine x. So that is another way of derive this curve. Okay, good. Now let's consider this function. This function is derived for all real numbers, right? So this curve this function is defined over the whole entire real numbers. And this function is not even, not odd. So therefore, we may sketch the whole entire domain. Is that correct? This function, if you put a negative x here, this is not changing. This is negative. Therefore, this is not order. Not order function, not even function. Now, the x, when x equals 0, y is equal to 1, right? So that is my y-intercept. Yeah. So this is equal to 1. this curve passing through this point. Now, y is equal to x, then x is equal to plus or minus pi over 2 and plus or minus 3 pi over 2, right? And plus or minus 5 over and plus or minus 7 pi over 2. Because we have to consider the whole entire domain, right? They are not symmetrical. The curve is not symmetric. Okay, so at those points, the curve is passing through, right? Half pi. This is passing through. This is passing through. This is passing through. This is passing through. Negative half 1. This one. And this one. So these points are points the curve passing through. Now, the first derivative is equal to 1 minus sine x. Because this one will never be negative, right? Therefore, the curve is always increasing, or horizontal tangent line. It's never decreasing. Now, the first derivative equal to 0. Then x will be plus or minus the first derivative is 0, which means sine x is equal to 1. Sine x equal to 1 is sine x equal to 1 is half x, right? And 5 pi over 2, and 9 pi over 2. Well, for negative sign is all negative 3 pi over 2, right? Yeah, negative 7 pi over 2, and so on. At these points, the tangent to the point, after the point is 0, so half pi. So at this point, the curve is horizontal. At this point, the curve is horizontal, right? At this point, the curve is tangent to the horizontal line. Yeah, second derivative equal to 0. Now, second derivative is what? Second derivative is a negative cosine x. Second derivative equal to 0. X is equal to half pi, right? Plus or minus half pi. Plus or minus 3 pi over 2. Plus or minus 5 pi over 2. Plus or minus 7 pi over 2. And so on. So at this point, there are points of inflection. Okay, that's good. At this point, sine x is a negative 1. So y derivative is equal to. So at this point, the slope of tangent is 2. The curve is tangent to this line, but because the derivative at this point is 2. And same as this one. Okay, same at 0. When x equals 0, no, the derivative is a negative 1. Yeah. Okay, let's see. See there. This is horizontal passing through this one here. This is something like this. And this is a tangent line. And this is a tangent line horizontal. This is a tangent line. And this is the point passing through. This is a tangent line horizontal. This is point crossing. So that is this is the curve for this x plus degree. At this point, x equals 0, we put this one, y derivative is equal to 1. So at this point, the tangent slope of tangent is 1. See, this is true. The tangent slope is 1 at this point. Okay, there's lots of details to consider. Okay, so that is basically the curve. Okay, horizontal tangent line. The slope of tangent is 2. Point inflection, because secondary equals 0. Point inflection. See, the slope of tangent is 2. And if you consider carefully, these will be matching all those that we have discussed in the derivatives. Then we consider another function, which is y equal to x minus cosine x. Now, this y is equal to, at x equal to 0, it's equal to negative 1, right? Because the function is not symmetrical, therefore we have to consider as much as possible. So this one means that the y-intercept is negative 1. So this is the point. This is the point, the curve passing through. And this first derivative is equal to 1 plus sine x. Right? So definitely this is non-negative. Therefore, this curve is not decreasing. It's not decreasing curve. And first derivative equal to 0, which means x is equal to 3 pi over 2, right? 7 pi over 2, 11 pi over 2. For the negative side, negative half pi, negative 5 pi over 2, negative 9 pi over 2, and so on. So at these points, the slope of tangent is 0, which means at these points, the curve is tangent to the horizontal line, right? At this point, tangent line. At this one's tangent line is horizontal. Negative half pi, tangent line is horizontal. 5 pi, this is 5 pi, okay, horizontal. Okay, that's good. Now, the second derivative is equal to cosine x, right? So therefore, the second derivative equal to 0, x would be equal to plus or minus half pi, right? Plus or minus 3 pi over 2, plus or minus 5 pi over 2, plus or minus 7 pi over 2, and so on. So at this point and that point, they are point of inflection, right? Yeah. Let's take a look at the at this point, positive half pi. You put the derivative here. First derivative, it will be 2. So it means at this point, the slope of tangent is 2. It's 2. This is slope equal to 1. This is slope equal to 2. That means the curve will be tangent to this line. And same thing as this one. Now, this point, right? At this point, you put it here, the derivative will be equal to 2. So at this point, the tangent line will be this slope is 2. Okay. And at this point, at 0, put it here, the slope will be 1. So at this point, the slope is 1. The slope of tangent is 1. Yeah. At this point, slope is 2. Now, we can sketch the curve. Well, slope is 2. Slope is 2, right? Slope is equal to 1. So, like this, slope equal to 0. Slope tangent is 2. Slope of tangent is 0. And so on. Slope is 2. Slope of tangent is 2. Slope of tangent is 0. Slope of tangent is 2. Slope of tangent is 2 here. Slope of tangent is 0, and so on. Here, the curve is non-negative. If you check carefully, point inflection. That means at these points, they are point inflections. And many things matching our discussion. I put these two curves together because we can have a comparison, so we will have a better understanding. Now, these two curves you can also derive by draw y equals to x. Then you draw cosine curve. Then you consider as I did in x plus sine x, that you can add or subtract the cosine curve. You can derive this the same curve as we discussed. Well, I hope you can go over yourself. Then you will understand better. So this is very interesting. Now I have 6 episodes for this series, right? So you can go over see all these 6. Also, that I have other series of videos that consider curve sketching. other than those examples. If you're interested, you can take a look. Thank you for your watching.